So you're going to start with 5 of these pieces of paper that you should have picked up in class. Okay. And then what you're going to do is going to line them up like this, about an inch apart like that. Make sure you have 5 different pieces of color. All right. Then what you're going to do is take the bottom, fold it up. See, this is the top. So then you're going to take the bottom, fold it. Notice that there's this piece, this piece. So you have a gap there. Okay, these should be the same pieces of color. Okay, you're going to fold it at the bottom. Okay, and then turn it from top to bottom like this. Staple the top. Like so. Okay, so there's your fold. All right. So now let's go over what's going to be on the foldable. All right, now you'll notice that I have mine taped to a piece of paper, and that's what you want to do. You want to tape it or glue it to page 4 to put it in your journal. Okay. All right. So the top, we're going to label it parent functions. Okay. And this date is outdated. As you can see, I'm reusing one of mine from a previous year. You don't really need a date on that. All right. So the first part is say parent functions. Then you're going to fold it up. All right. And then the first thing we're going to look at is linear. All right. So the first thing you want to do is make a table. Basically, the table for linear is the x and y values are the same. So x's are -2, -1, 0, 1, 2. Y's are -2, -1, 0, 1, 2. Okay. Now, the first difference in y, meaning the difference between the y values, is all 1. Okay. If that happens, then you know it's a linear function. Okay. The graph of a linear function is this. The domain is all real numbers, the range is all real numbers, and the function is f of x equals x. So if you would update the linear parent function. All right, so now let's look at quadratic. All right, so in quadratic, and well, that's too dark. Wait, sorry, a little adjustment in lighting here. All right, so the table is the x's are -2. When x is -2, the y is 4. When x is -1, the y is 1. When x is 0, the y is 0. When x is 1, the y is 1. And when x is 2, the y is 4. I'm going to pause for a minute because I don't know about you, but this is kind of hard to read. So I'm going to change some lighting real quick and I'll be right back. Wait for it. Wait for it. Bam! Look at that. Good lighting now. Which, if you ever make videos, lighting is very crucial to get a good video. So there you go. If you want to start your own YouTube channel, understand lighting. All right, now, if the first, no, here we have the first difference. They're not the same, but in the second difference, meaning the difference between 4 and 1 is -3. The difference between 1 and 0 is -1. But here, the difference between -3 and -1 is 2, and so on. So the second difference is the same, then we know it's quadratic. Okay? And this quadratic parent function is this. Now, the domain is all real numbers, and the range is y greater than or equal to 0, meaning all of the y values are greater than 0. And the function is f of x equals x squared. Now, I've written this, but we really need to write domain as negative infinity to positive infinity. They're both the same, but when you take the AP test, I think they write domain arranged that way, okay? And so that's correct, but again, if you were preparing for the AP test, which eventually you'll take that, this would be bracket 0 to infinity, okay? And I should actually take a step back here for linear, and that should be negative infinity to positive infinity. Both are acceptable, but just know that the AP test is looking for this, okay? All right, so now let's move to cubic. All right, so the cubic function, okay, when x is negative 2, y is negative 8. When x is negative 1, y is negative 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 8. Now you notice the first difference. So the difference between these values is not the same. The second difference is not the same. But on the third difference, you notice they're the same, so you know it's cubic. Okay? And notice these are specific points. So this is negative 1, this is 1, 1, this is 2, 8. All right. Now, the domain and range, the double R is acceptable. And if you were given a test in my class, it'd be an acceptable answer. But the AP test, you'd lose a point by not writing, if I'm correct, and your calculus teacher will go over this a couple years from now. But if I'm correct, they want the negative infinity to positive infinity for domain and range. All right, the cubic function is f of x equals x cubed. So now let's look at exponential. All right, exponential. So when x is negative 2, the y is 0.25. When x is negative 1, the y value is 0.5. When x is 0, the y is 1. When x is 1, the y is 2. When x is 2, the y is 4. Okay? Now, here, we have an asymptote of y equals 0. Okay? And we'll get into asymptotes later. The function is this. Domain is all real numbers, and again, which we're going to write negative infinity to positive infinity. And y is greater than 0, which we're going to write as parentheses 0 to infinity. Now there's common ratios in y, meaning if you take 0.5 divided by 0.25, you get 2. If you take 0.5 divided by 1, you get 2. If you take 2 divided by 1, you get 2. So when you divide the y values, there's a common ratio of 2 in this case. So it's exponential. The function is f of x equals b to the x power, where the 2 is the b value in this case. All right, now let's take a look at logarithmic. All right, so when x is 0, the y value is undefined. When x is 1, the y value is 0. When x is 2, the y value is 1. When x is 4, the y is 2. When x is 8, the y is 3. Now in this case, you have x equals 0 as an asymptote, and there's your function. Domain is x is greater than 0, but again, we're going to write it as 0 to infinity. And the range is all real numbers, which we're going to write as negative infinity to positive infinity. And then they have common ratios next. So 8 divided by 4 is 2, 4 divided by 2 is 2, 2 divided by 1 is 2. And that's the logarithmic function f of x equals log base b of x. All right, so now let's look at cubic. All right. Now in this case, we have the third difference in x, meaning the difference of the x values, you'll get the same difference on the third, okay? When x is negative 8, y is negative 2. When x is negative 1, y is negative 1. When x is 0, y is 0. When x is 1, y is 1. When x is 8, y is 2. All right. Here's your exponential graph. Notice I graph specific points like negative 1, negative 1, negative 8, negative 2. The domain and range, all real numbers, that symbol is acceptable, but again, we're going to write it as negative infinity to positive infinity and negative infinity to positive infinity. This is the cube root function. F of x equals cube root of x. Now let's look at square root. That's a bell. All right. So here, when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. When x is 16, y is 4. You'll notice you have a second difference in x, meaning the difference of the x values is the same on the second difference. All right, your function is this. Notice I use points from the table. Domain, this is acceptable, is x is greater than or equal to 0 and y is greater than or equal to 0, but I would write it as bracket 0 to infinity and bracket 0 to infinity. Either one of those is acceptable, but I believe, again, the AP test is going to want that as your correct answer. That's the square root function. F of x equals square root of x. All right, so here, now we're looking at absolute value. This is absolute value, and this is rational. Let's look at absolute value first. When x is negative 2, y is 2. When x is negative 1, y is 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. Your first difference is the same. There's your absolute value graph. And then domain, again, r is fine, but I would write it as negative infinity to positive infinity. And range is y greater than or equal to 0, which again I would write as bracket 0 to infinity. That's the absolute value. All right, now let's take a look at the rational. When x is negative 2, y is negative 0.5. When x is negative 1, y is negative 1. When x is 0, it's undefined. When x is 1, y is 1. When x is 2, it's 0.5. Here's your rational graph. And when you're graphing rational graphs, you just need this point and this point, and then you know the curve. Okay? Here, it's all numbers. X does not equal 0, but we're going to write it as from negative infinity to 0 or 0 to positive infinity. And that would be your acceptable answer. Okay? So from negative infinity to 0 or 0 to infinity. Again, both of these are mathematically acceptable, but we're going to want this answer because that's what the AP test a couple years from now is going to want the answer in that form. And that's your rational function. F of x equals 1 divided by x. And I forgot to say, the absolute values, f of x equals, these are the absolute value symbols, the absolute value of x. All right, last part of your foldable, to find an inverse. And when we write inverse, it's f inverse of x. So number one, graphical, reflect over the y equals x line. They're inverses if they reflect over the y equals x line. Now, in that case, to test for that, we test for an inverse using the horizontal line test. All right, number two, algebraic. To find an inverse using algebraically, method one, you switch the x, y values and resolve for y. Method two, use compositional functions to determine the inverse. So f of f inverse of x equals x, and if f inverse of f of x equals x, then we know, there's another bell. It's a long bell. Then we know, since they're both x, that they're inverses. Now note, domain and range will flip if they're inverses. Now, don't stress too much about this inverse page because we're not going to get inverses yet, but when we do, this page will connect to what we did with the inverse function, or with the parent functions, okay? So, with that, If you got all of that, then you're good for class. If not, then I can create this folder and go over all of it with you again in class. Okay? So with that, have a wonderful Wildcat day.